This is what we looked at before. So the 2.6 represents what? Y-intercept, the initial value. And what's the 0.4 tell us about the graph? Growth factor. And is this increasing or decreasing? Decreasing. And why does it end up decreasing here? Yeah, that 40% of the previous value each time. So it's decreasing by 40% on here. And what I want to do is change this so that we have, if we're thinking in terms of logs, we want to have a base 10. So the growth factor here, I want to make that 10. So I'm going to go in, and I did this during break, but I'll redo it here. Let's see, object properties. And instead of going from 0.1 to 5, let's let this go up to 10. So now I can pull this all the way. Oh yeah, it's growing really fast now. And let's let our initial value be 1. So this is just kind of a fancy way to write y equals 10x. All right, and the inverse of this would be what? Y equals 10x. Oh, we almost have it here from the beginning of class. In exponential form, if we write that in log form, what would this be? Log to the base 10. What? We know the result is going to be the exponent. Actually, let's make this y and this x. I'm going to help out here until it's the last part of class. Everyone gets tired on here. So the inverse of this would be y equals log of x. So let's look at what the graph looks like. And we didn't do a huge emphasis on this, but do you guys remember what the there's a property for a function and its inverse when you graph those? Maybe what we'd start with to think it through. What happens with the x and y values when you have a function and its inverse?
They're opposite.
Okay, let's go back. What happens?
It's a mirror. It's a mirror.
It is. It's going to reflect about a line. The inputs and outputs switch when you do a function and its inverse. Like the exponent, this would be the result, and then you get the exponent. If you have the exponential form, you put in an exponent, you get a result. The x's and y's switch. So Paul's on the right track here. It's going to be a reflection about the y equal x line. So if we make a function here, so I'm going to say g of x equals x, and I'm going to graph that. Ooh, what happened there? Oh, g was already used. Can I undo? Let's see, g was, I think, was already used for the growth factor. Let's make h. I don't think that one's been used. h of x equal to x. All right, so that's the graph of y equals to x. The slope is 1, and the intercept is 0. This would be like 1, 1, 2, 2, 3, 3, and so on. And if we now do the graph of log of x,
shouldn't it be log of y equals x for the inverse?
Let's see, log of
According
y.
to this sheet you gave us, that's how that should line.
If this were changed, or 10 to the y is equal to x, x would be the result.
Okay, I didn't see that you switched it there. That's right.
Okay.
Okay.
And I switched it because when we use Geogebra, we want to put x in there.
Right.
So let's see. I'm going to just say I of x just to get a different function name is equal to, and I think let's make sure. Log, oh, they have a log to the base 10 on here. And I'll zoom here so you can see what we got going. So this is log to the base 10, and let's just do of x here. And if we graph this, then this is like Paul was saying, it's the reflection about the y equal x line. So this is y equals 10 to the x, and here's y equals log of x. Their inverse will be reflections about the y equal x line. All right, so that would be the main thing to take home there. If we wanted to do continuous growth, what would we have for a growth factor here? Continuous growth would be, and I'll help out here. Yeah, this would be e, so we should make this like 2.7. And as we go down to 2.7, what's happening to the exponential growth curve? Not as steep on there, but the initial value stayed the same. So if this is not as steep on the growth, what do you think about the natural log, if we were to do the natural log? This one was
It's going to become more steep.
over here, but yeah, so then we'll kind of see that. So let's go I, the next one is j, so I'm just going to put it in j of x equals ln, so natural log of x. So kind of like San was saying, this one ends up increasing faster, it's more steep. Still goes through that point, because when you have, when the result is 1, it says anything raised to the 0 power is equal to 1. So that point is always going to be the same, but then it goes up faster. All right, so just wanted to go through that with you. Let's take a minute. Any comments then or questions?